For generations, astronomers believed that the universe's earliest stellar systems would remain forever beyond our reach. The first chapters of cosmic history unfolded billions of years ago, so far away that even the most advanced telescopes could detect little more than faint smudges of light. Scientists could build detailed computer models of the young universe, but direct evidence of its oldest star systems remained frustratingly limited. That changed with the arrival of the James Webb Space Telescope. Designed to observe the universe in infrared light, Webb can see farther into space, and therefore farther back in time, than any space observatory before it. Soon after beginning scientific operations, it revealed something that immediately captured the attention of astronomers around the world. Hidden within one of its deep field images was a distant galaxy unlike most others. Around this galaxy were several tiny but unusually bright points of light that appeared far too compact to be ordinary galaxies. At first glance, they seemed insignificant. But closer examination told a very different story. The distant object, nicknamed the Spark Galaxy, lies approximately 9 billion light-years from Earth. Because its light has traveled for billions of years before reaching us, observing it is like looking into a much younger universe. Instead of seeing the galaxy as it exists today, Webb shows us what it looked like long before our solar system was born. What made the discovery remarkable wasn't only the galaxy itself, it was the brilliant object surrounding it. Researchers found evidence that these compact sources are likely globular clusters, some of the most ancient types of stellar systems known. Unlike open star clusters, whose stars slowly drift apart over time, globular clusters are tightly packed spheres containing hundreds of thousands, and sometimes millions, of stars held together by gravity. Even within our own Milky Way, globular clusters are extraordinary. Many formed more than 12 billion years ago, making them among the oldest surviving structures in our galaxy. They have endured almost the entire history of the universe, preserving valuable clues about the conditions that existed when galaxies were first taking shape. For decades, astronomers suspected that similar clusters should exist throughout the distant universe. The challenge was that they were simply too small and too faint to observe directly across billions of light-years. Webb changed that. Thanks to its extraordinary sensitivity, the telescope was able to separate these compact star clusters from the surrounding galaxy with a level of detail that previous observatories could never achieve. Instead of seeing only blurred patches of light, scientists could identify individual stellar systems that had formed when the universe was still relatively young. This transforms globular clusters into something even more valuable than beautiful objects. They become cosmic time capsules. Because these clusters contain stars that formed during the universe's earliest periods, they preserve information about the environment in which the first generations of galaxies evolved. Their ages, masses, chemical composition, and distribution provide important evidence for understanding how galaxies assembled over billions of years. The timing of the discovery makes it even more exciting. Looking 9 billion light-years into space means looking 9 billion years into the past. Rather than studying globular clusters after billions of years of change, astronomers are observing them much closer to the era in which they originally formed. This offers an opportunity to test long-standing theories against real observations instead of relying entirely on computer simulations. Scientists found that these distant clusters appear incredibly compact and surprisingly massive, suggesting that star formation in the early universe may have been both rapid and highly efficient. If confirmed by future observations, this could reshape our understanding of how quickly galaxies built their first generations of stars. The discovery also demonstrates the unique power of infrared astronomy. As the universe expands, light from extremely distant objects becomes stretched into longer wavelengths. Much of the light emitted by ancient galaxies has shifted beyond the visible spectrum and into infrared light by the time it reaches Earth. Traditional optical telescopes struggle to detect these signals, But Webb was specifically designed for this challenge. By capturing infrared light with unprecedented sensitivity, it can reveal objects that remained hidden for decades. What once seemed permanently lost beyond the limits of observation is now becoming accessible to direct study. The Spark Galaxy and its surrounding globular clusters represent far more than another distant astronomical discovery. They offer a rare glimpse into an era when galaxies were still assembling and the universe was only a fraction of its current age. For the first time, astronomers are not simply imagining what some of the earliest stellar systems looked like. They are beginning to observe them directly. And this remarkable discovery is only the beginning. The next stage of the investigation would reveal that the universe itself played a crucial role in making these ancient star clusters visible, using one of nature's most extraordinary phenomena to magnify the distant past. Discovering the ancient star clusters surrounding the Spark Galaxy was only the beginning. The next challenge was even greater. Finding these objects was remarkable, but understanding what they could reveal about the early universe required a way to measure their age, composition, and origin with far greater precision. For decades, this had been one of astronomy's biggest obstacles. Scientists could estimate the ages of globular clusters inside the Milky Way because those systems are relatively close. Their individual stars can be studied in great detail, allowing astronomers to reconstruct their long history. But performing the same analysis for clusters billions of light-years away was nearly impossible. At such enormous distances, even the largest telescopes could only detect faint points of light with limited information. The James Webb Space Telescope changed that picture completely. Using its highly sensitive infrared instruments, Webb captured light across multiple wavelengths, allowing astronomers to analyze these distant stellar systems in ways that were previously impossible. Every wavelength carries information about the stars inside a cluster, including their temperature, chemical composition, and stage of evolution. By comparing this data with sophisticated computer models, researchers can estimate when these ancient star clusters first formed. Instead of relying only on theory, scientists now have direct observations from a much earlier chapter of cosmic history. One important clue came from the light emitted by the clusters themselves. Researchers found little evidence of the strong emission associated with regions where new stars are actively forming. This suggests that the clusters had already completed most of their star formation long before the light we observe today began its journey across the universe. In other words, these were already mature stellar systems during an era when many galaxies were still rapidly growing. That finding supports the idea that globular clusters formed surprisingly early in the history of the universe. If confirmed through future observations, it would mean that some of the oldest stellar populations assembled much faster than many previous models predicted. But another extraordinary factor made this discovery possible. The Spark Galaxy is visible because of a phenomenon first predicted by Albert Einstein in his theory of general relativity, gravitational lensing. According to Einstein's theory, massive objects bend the fabric of spacetime around them. As light from a distant galaxy passes through this curved space, its path is bent, causing the background object to appear brighter, larger, and sometimes even distorted. Between Earth and the Spark Galaxy lies the massive galaxy cluster SMACS 0723. Its enormous gravity acts like a natural cosmic telescope, magnifying the distant galaxy behind it. Without this effect, the ancient globular clusters would likely have been far too faint for Webb to detect. Nature itself helped build the world's most powerful observatory. The gravitational lens produced another fascinating effect. Some of the same globular clusters appeared multiple times in Webb's images. These repeated images were not separate objects, they were different paths taken by the same light as it traveled through the warped space surrounding the galaxy cluster. By matching these repeated images, astronomers confirmed that the compact star clusters truly belong to the spark galaxy rather than being unrelated objects along our line of sight. This gives researchers far greater confidence in their measurements and helps refine models of both the distant galaxy and the gravitational lens itself. The discovery also highlights the incredible partnership between advanced technology and the natural laws of the universe. Webb provides unmatched infrared sensitivity, while gravitational lensing supplies the extra magnification needed to reveal objects that would otherwise remain invisible. Together, they allow scientists to study regions of cosmic history that once seemed permanently beyond our reach. Researchers are now planning similar observations of other distant galaxies located behind massive galaxy clusters. Each new target offers another opportunity to search for ancient globular clusters and improve our understanding of when the first generations of stars and galaxies appeared. Every new discovery helps answer one question while raising several more. How quickly did galaxies assemble after the Big Bang? Why did some stellar systems form so efficiently? And could even older globular clusters still be waiting to be discovered farther back in time? The James Webb Space Telescope has not rewritten the history of the universe, but it has opened an entirely new window into its earliest chapters. For the first time, astronomers are moving beyond educated guesses and computer simulations. They are directly observing ancient stellar systems that have traveled across billions of years to reach us. Each image is more than a beautiful photograph. It is a message from a time when the universe was still young, offering a rare glimpse into the birth of galaxies and the earliest generations of stars. As Webb continues its mission, one thing is becoming increasingly clear. The deeper we look into the cosmos, the closer we come to understanding how everything we see today first began.